viewers, in today's class, we are going to discuss one important and conceptual integral, right? So here we have to find the value of this integral, that is 0 to infinity e raised to minus 2t sine t divided by t, right? So viewers, in our earlier video, we have seen one integral which was similar to this integral, except that in that case we have this t in the numerator, right? So in this lecture we'll see this integral in which this t is in the denominator of sine of t, right? So let us start. So now to evaluate this integral, we'll make use of the concept of Laplace transform, right? So we'll see how easily we can solve these kind of integrals using the properties and definition of Laplace transform, right? So now to apply the concept of Laplace transform, let us consider the integral I, that is 0 to infinity e raised to minus st and sine of t divided by t, right? So here if we take s is equal to 2, then this integral reduces to this one, right? So here our aim is to find the value of this integral in terms of s, right? And once we obtain the value of this integral I in terms of s, then we can easily find out the value of this integral by taking the value of s as 2, right? So our aim is to find a more general integral and then to obtain the value of this particular integral by taking s is equal to 2, right? So we have considered this integral I as 0 to infinity e raised to minus st and sine t over t, right? Okay, now let us consider this function as f of t, right? So if we take f of t as sine t divided by t, then we can see that this integral I, it becomes 0 to infinity, and we have e raised to minus st f of t dt, right? So now we have obtained this integral, and we can easily see that this integral is nothing but the Laplace transform of this function f of t, right? Because we know that the Laplace transform of some function, say f of t, is given by this integral, that is 0 to infinity e raised to minus st f of t dt, right? So this integral I is now reduced to the Laplace transform of this function f of t, which is sine t over t, right? So now here we'll write sine of t over t, right? So once we find the Laplace transform of sine t over t, we'll get the value of this integral I, right? So here now we'll use an important property of Laplace transform. Now see, we know that the Laplace transform of g of t divided by t is given by this integral, that is s to infinity, and the Laplace transform of this function g of t, right? Where g of s is the Laplace transform of g of t, right? So here to get the value of this expression, that is Laplace transform of sine t over t, we'll use this result, right? So we can now have I is equal to Laplace transform of sine t over t. So if we compare this expression sine t over t with this one, then we can see that here we have in the denominator t. Here also we have the denominator t, and g of t is sine t, right? So g of t is equal to sine of t. So Laplace transform of sine t over t can be written as this integral, so s to infinity and g of s. Now g of s is the Laplace transform of g of t, and g of t is sine t. So we have the Laplace transform of sine t, right? And we know that the Laplace transform of sine t is 1 over s square plus 1, right? We know that the Laplace transform of sine at is equal to a divided by s square plus a square, right? So if we take a is equal to 1, then the Laplace transform of sine t is 1 over, because a is 1, so we have 1 over s square plus 1 square, that is 1. So here is the result. So the Laplace transform of sine t is 1 over s square plus 1. So now we can take the value of g of s as 1 over s square plus 1, right? Okay, so now what we will do here we have g of s and ds also, right? So now we have a simple integral here, because we know that integral dx over x square plus 1 is equal to tan inverse of x, right? And here we have the integral in terms of s, and we have 1 over s square plus 1. So the integral is tan inverse of s, and the limits of integration are from s to infinity, right? So now we can substitute the limits and we'll take the difference. So we have tan inverse infinity minus tan inverse of s, and tan inverse infinity is pi by 2, and this is simply tan inverse of s, right? So now we have this expression, right? So tan inverse infinity is pi by 2, because tan of pi by 2 is equal to infinity, which is not defined, right? So viewers, the value of this integral in terms of s is given by pi by 2 minus tan inverse s, right? And we can see that this value is a function of s, right? So the value of this integral depends on the value of s. So now if we take different values of s, or the permissible values of s, then we can evaluate different integrals, right? So here if we take s is equal to 2, right? In this integral, if we take s is equal to 2, then we get this integral, because here we have e raised to minus 2t, and here we have e raised to minus s of t, right? So taking s is equal to 2, the value of this integral I is pi by 2 minus tan inverse of 2, right? So the value of this integral is equal to pi by 2 minus tan inverse of 2, right? So viewers, this is how, by making use of the concept of Laplace transform, we can easily find out the values of these type of integrals. Now suppose we have to find the value of this integral, right? Now see, if we compare this integral with this one, then see, here we have sine t over t, here also we have sine t over t, and here we have e raised to minus t, and here we have e raised to minus st. So the value of s is equal to 1, right? And if we take this value of s is equal to 1 in this result, then the value of this integral is pi by 2 minus tan inverse of 1, because s is 1, so this is pi by 2, tan inverse 1 is pi by 4, and this is 4, then this is 2 pi minus pi, that is pi by 4, right? So the value of this integral is pi by 4.